Let us do a comparison between E1 and E2 mechanisms. We know E1 is basically a carbocation mechanism, so tertiary reacts faster than secondary, and the primary carbocations are highly unstable. So generally they don't undergo a reaction by E1 mechanism. In the case of E2, tertiary reacts slower because the approach of the base is going to be very difficult in the case of tertiary derivatives. So that's the reason tertiary reacts slower compared to secondary compared to primary. And in the case of base, E1 reaction does not have this is a unimolecular reaction. That means the rate determining step does not use the concentration of the base. So there is no involvement of strength in the E1 reaction, whereas for the E2 reaction, the rate depends on both the concentration of the starting material and the base. So base is involved in the rate determining step, so the strength of the base is very important. And when we talk about leaving group, in both the cases leaving group actually is involved in the reaction, and especially in the case of E1, the loss of leaving group, how quickly it can be lost, leads to the carbocation. So this is the rate determining step. So a good leaving group favors carbocation mechanism very effectively. And of course in the rate determining step, loss of halogen is or the loss of leaving group is involved in E2 also. So that means a good leaving group enhances the reaction even for E2. And E1 mechanisms are favored by polar protic solvents, whereas E2 generally they are favored by polar aprotic solvents, and the reactivity may also differ depending on the solvent.